Okay, what we need to do at the beginning is we need to find the general term. Okay, remember the general term is given by this formula, Tn equals A multiplied by R to the power of n minus 1. Okay, also remember A is your first term and R is the common ratio between the terms. Now, in this example here, we can see that the first term is 8. So that means that A is equal to 8 in this example. To get the common ratio, we need to remember that we need to take any term divided by the term before it. So, for instance, you can take the second term divided by the first term. That would be 4 divided by 8, giving us an answer of a half. And just to make sure that we are correct, we can try another set of terms. For example, the third term divided by the second term. That would be 2 divided by 4. And as you can see, that is also giving us a half. Therefore, we definitely have a constant ratio between the terms. The A value is 8, the R value is a half. Putting that into our general formula, we get Tn equals A, which is 8, multiplied by R. Put that in brackets because it is a fraction, to the power of n minus 1. This is now the general term of the sequence. Remember, also, we do not multiply the 8 and the half together, okay? In other words, it would be wrong if you wrote 4 to the power of n minus 1. That would not be correct. That would be a mistake. We are not going to do that. Right. Now, to determine the value of T7, what we need to do is we need to substitute n equals to 7 into the general term. Okay, that is going to be our method, whether it is the 7th term or the 16th term or the 24th or the 300th, always going to be replacing n in that particular case. All right, so in other words, for question number 1, we can say that T7 is equals to, and then we simply write our formula down, but we replace n with 7. Okay. Remember, there are 2 places where we see n. Here is a subscript, and here is an exponent. We have to replace both of those with 7. You can then go and work it out. So this is going to be 8 times a half to the power of 6, which we can then, of course, evaluate on our calculator. So if I just take, for example, the computer's calculator over here, it's going to be a half to the power of 6, right? So a half to the power of 6, and then times that by 8, and it's 0,125. You can write 0,125. You could also write 1 over 8 if you prefer fractions. The 7th term is 1 over 8. Now, I just want to point out, we could have done this in a slightly different way. We could have done this by simply continuing the pattern. You can see 8, 4, 2, 1. Every time you are timesing by a half, the next number is going to be a half. The next number is going to be a quarter. The next number is 1 over 8. Right, so if you count 1, 2, 3, 4, 5, 6, 7, you will see the 7th term, in fact, is 1 over 8. Hopefully you can now see that there are 2 ways you could have done this, right? You could have substituted into the general term, or you could just continue with the pattern, and that can also give you the correct answer. Right, question number 2 is asking how many terms are there in the sequence. Now, if you look at the sequence, we do have the last term. Okay, now if we continue with the pattern, we can actually find this answer very easily. Let's see what's going on there, right? 8, 4, 2, 1. And then a half, and then a quarter, and then an 8th and a 16th, 1 over 32, 1 over 64, 1 over 128, 1 over 256, 1 over 512, 1 over 1024, etc., etc., etc. 1 over 2048. Now that, in fact, is our last term. So if we count now how many terms there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is your 15th term. Therefore, there are 15 terms in the sequence. So we can do that. We can say, therefore, there are 15 terms. However, this could get a little bit clumsy depending on what that last term is. Because if the number is small enough, of course, you can continue the pattern. But what if it was a situation where maybe it was not possible to do this? What other method could we then use? So the other method that we can use is we can set the last term equal to the general term and then solve n afterwards. Okay, set the last term equal to the general term and then solve n. Right, so we have this general term over here. Okay, so we can take that general term and we can set it equal to the last term, which is 1 over 2048. Now we need to try to solve n, okay? So the first thing we're going to do is divide both sides by 8. Whatever the a value is, divide both sides by the a value. Okay, so we're going to divide both sides by 8. Now, the easy way for me to do this, just with this calculator here, I'm going to work out that 2048 and then times it by 8, 16,384. So I know when I divide both sides by 8, I'm going to get a half to the power of n minus 1 is equals to 16,384. Right. Now, the next thing we can do is we can try to figure out what power of 2 is giving 16,384. So let's have a look. Okay, so 2 times 2 equals 4. Then 8. Okay, that's 2 to the power of 3. 2 to the power of 4. 2 to the power of 5. 2 to the power of 6. 2 to the power of 7. 2 to the power of 8. 2 to the 9. 2 to the 10. 2 to the 11. 2 to the 12. 2 to the 13. 2 to the power of 14 gives this. Okay, so we can write this then as a half to the power of n minus 1 equals 2 to the power of 14. Now, it's very useful to remember that if we have a base with a positive exponent, we could reciprocate the base and write it as 1 over what it is, and then we can change the exponent into a negative number. Now, this is very useful because we can now take 2 to the 14, and we can take the 2, and we can write it as a half. Now we need to change 14 into negative 14. The reason why we would want to do this is so that now we have the same bases on both sides. We have the same bases on both sides. Right? So now we equate the exponents. So we can write the one exponent equals to the other. Now, solving this is going to give us n minus 1, well, n equals negative 14 plus 1. So this is giving us n equals negative 13. Now, for the challenge, you will notice that this answer over here is different from if I had to continue the pattern, right? And then figure out there are 15 terms. The question is, why am I getting an answer of negative 13? So take a look at this working out and see if you could figure out where I went wrong. Alright, so it's important to be able to first just double check our work. Okay, the first term is definitely 8. The R value is definitely a half, and this formula is correct. The question is asking how many terms, and we have 1 over 2048. I then took 1 over 2048 and I divided it by 8. Okay, so that is then giving me not 16,384. Must be careful here. It's actually 1 over that. Okay, so it's 1 over 16,384. There's the error. Okay, so immediately this is actually going to be a half to the 14. In other words, this piece of theory, which is useful, is not necessary this time. Okay, so this is actually positive 14, and so the answer here is then going to be n equals to 15, which definitely corresponds with the fact that there are 15 terms. Alright, so the suggestion is, of course, be careful when you're using your calculator, and if you're getting an answer which does not make sense, remember to go back and check your work. Right, now let's take a look at question 3. So question 3 is asking, is 1 over 512 a term in this sequence? If we continued the pattern, you will definitely see, yes, it is a term in the sequence. Right, so continuing with the pattern actually makes certain questions very, very easy. Now, if we had to do this the long way, is this a term in the sequence? All we have to do, and I'm going to use number 2 as an example, we just have to set the formula equal to that number, okay? So now, let's see how this is going to play out. Right, so 1 over 512 divided by 8 is going to become 1 over 64. 1 over 64 is the same thing as a half to the power of 6. So then n minus 1 is going to equal 6. And so n is going to equal 7. The 7th term is 1 over 512. 1, 2, 3, 4, 5, 6, 7. Now you will notice, hang on. The 7th term is not 1 over 512. Okay, so let's see, what did we do wrong here? Right, so what we did wrong was this calculation, of course. Again, be careful when you're using your calculator. This should be 1 over 4096. Now, that is actually going to be a little bit different. So if I look at 2 times 2, that's 2 to the 2, 2 to the 3, 4, 5, 6. This is 2 to the power of 6, 7, 8, 9, 10, 11, 12. Okay, so this is a half to the power of 12. This is then 12. And so the answer is going to be n equals 13. Aha. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. The 13th term is 1 over 512. Okay, alright guys. So I hope that this video helps you to understand geometric sequences a little bit better. These questions over here are very, very common questions that you will find in a lot of tests and a lot of assignments. I hope that you understand the ideas that I brought across to you. And remember, always double check your answers to make sure they make sense, to make sure that you are getting those questions right. So guys, I hope that you enjoy your math, and remember to like and subscribe, and I will see you next time in the next video.